Hey guys, how's it going? I'm Animesh from Learn How to Train. I have been a fitness coach for the last 6 years and I identify myself as a fitness educator. So, my goal, my mission is to empower and educate people about training concepts that I learn about so that they can gain autonomy over their own training, right? Because as you go through life and adapt through life, your constraints and your goals always keep changing. And your training system kind of has to follow through with it. So I help I help people build their own training systems that can adapt along with them, and then coaching just becomes like a piece of the puzzle and not the sole thing that you should be dependent on for training. That's very important to understand, right? Because some people and my content and my stuff is specifically for people that are curious and actually want to gain autonomy over their own training, right? So I agree that there's a lot of people that want their stuff taken care of 24/7. They want their programs DIY. They want their programs custom made. They want constant supervision over their training, and they don't want to put their minds into it. And then there are coaches that are self-educated to the point that they've made a career out of this. Now, what about people that are curious? They want to educate themselves about their training, gain more autonomy over their training, and to the point that they don't want to, just like get into this as a full-time career and do it for other people, but they want to do it for themselves, or maybe they are trying to do it as a career. Either way, this is the audience that I'm trying to address. And today, I want to talk to you guys about some super fun things, super fun concepts that I've been really passionate about for like the last 3 years. I got into it heavy during the pandemic days, but now I see these concepts kind of making their way into the quote unquote the mainstream. They're not quite mainstream yet, but they're also, like I see these concepts being talked about in like a couple of different fields. So that's very interesting to see, which is just telling me that 5 years down the line, this is going to be like the talk of the town, so to speak, and everyone's going to be talking about it. Everyone's going to be modeling their training behind these concepts. So I want my audience, which is quite niche by itself, I want you guys to have an unfair advantage, have like a head start on things. And again, I'm not giving you like a magic pill or something. I'm just giving you some insights so that you can ask better questions, right? And you have more thoughts to weave your own stories and ask better questions and get more curious about things and maybe apply it in a few different places. So what I'm talking about, we'll get into it, and this is like an open conversation, right? This is not like a presentation like the last video I did. This is just an open conversation. So just some insights that I would like to share with you guys. What I'm talking about is ecological dynamics and broader term systems thinking. So ecological dynamics and systems thinking, again, if you're like a regular gym goer, you've always had like a standard gym experience, maybe you're like doing following one school of thought like CrossFit or bodybuilding or something like that, you've probably not heard about this. And this, to be really honest, again, is a concept from ecology and systems thinking, which are much broader fields of studies that that are just giving you a lens to look into fitness. They've got nothing to do with fitness specifically or health specifically, but they are just like these broader fields of studies that you can use as lenses and then look into your training, and things start making sense at a level that is beyond answers, right? Because the problem with specific answers or having like very specific solutions to things is that people are individualistic creatures, and there's a term for it. People are non-ergodic in nature. So non-ergodicity and ergodicity is a concept that we get from chemistry, right? Some chemist came up with this concept, if I'm not wrong. But non-ergodic in nature, what does that mean? Being non-ergodic in nature means, for human beings, that means that when you look at a sample size of human beings, like let's say when you're looking at like a bunch of different human beings or all human beings, let's take that as a sample size. No two individuals have had the same journeys through time. Think about that, right? Let that sink in. Think about it. I'll say it again. No two human beings have had the same experiences through time, right? It can be human beings that, no, it's got to do with like many different reasons. Number one, the constraints that are placed on these human beings are completely different, right? You and I don't have the same life experience. No two people can have the same life experience. We can take it to its logical extreme and say that, let's say in a control setting, two people spend their entire lives in the same house, and they grow up, they're born at the same time, they grow up in the same environmental constraints, and they spend, like, let's say 25 years worth of time, and we are observing them at the point at which they have spent 25 years worth of time, right, at the 25th year mark. On one specific day we are observing these two human beings. Even then, even though they're born at the same time, they've grown up in the same house, and they've pretty much had the same environmental constraints, even then they are not going to have the same experience shaping them up through time, through all these 25 years of time. And that is why they're extremely individualistic human beings, right? This happens because humans in nature are complex and adaptive, right? They're complex systems that are communicating with their environment, and they're open to their environmental constraints. So things that are happening in the environment, how they perceive things, and things that are affecting them from the environment are actually bringing about changes in them. And the changes that are happening to an organism that is so complex. Like, if you think about what a human being is, right, an individual is an organism which is like accumulation of, it's this amalgamous system of organ systems, and then organ systems are made up of organs are made up of tissues are made up of cells are made up of subcellular matter. So the levels to which you can start, taking this to, is just so complex, it never ends. We know that we can dig down to a certain level, subcellular matter, we can go beyond that, but there's a certain point until which we know things exist, but we know that there's a lot more levels that we do not even know that exist, right? We're limited by our current scientific understanding and technology. So human beings are extremely complex. So when a certain individual that is a human being, that is a complex system, and that has the capacity to constantly adapt to its surroundings. This is another thing about human beings. Since we are openly communicating with the environment, we are also quite adaptive, and that is just a survival mechanism. Because imagine if you were not adaptive as an organism, as a system, right? And you would be at the mercy of your environmental changes, right? Like, let's say if you're just an organism that's born to bear a certain temperature, and suddenly the temperature changes, or we take you and we place you in an environment where the temperature and everything, all the environmental constraints are completely different. If your body did not have the capacity to adapt to those constraints, you would not survive, right? So that's why we are given this complexity, and we are given this ability to adapt to our surroundings. That's why we are open systems. So human beings, they can be classified as complex adaptive systems. So when we are observing human beings, we do not just observe a human being in control, in isolation. We observe them within the context of their environment, which is known as the ecology. That is basically what gives you the whole field of ecology and all the studies in ecology. So in ecology, you look at systems that are either closed to their environment, and you know how those systems work, or you look at systems that are open to the environment, that are adaptive in nature, and how those systems work. They'll work in two different ways, and that is basically getting into a little bit of systems thinking. Coming back to non-ergodicity, so human beings, no two human beings have the same experiences through time. So when we say that something works, like, let's say we have specific solution, let's like constrain all of this information down and talk specifically about health and fitness. Let's say we have a specific solution that we have come up with, and we say that we did this study on 60 people, and these were our findings, and according to this, we have concluded that this is a specific solution according to this study on 60 people. Let's take this solution and apply it to all of humanity. If we do that, that's not going to do justice to everyone. Neither is that going to be an appropriate solution, because just because it works for 60 people, or just because it worked within the constraints of that study, does not mean that these findings apply to the entire human demographic at large, right? Why? Because humans are non-ergodic in nature, they're complex adaptive systems, and they not two of what the fuck? Okay. Fucking, alright, I lost track of my thought. So no two people basically have had the same experiences through time, and they're two individual human beings. So at some point, this solution that you're trying to apply is going to break. It's going to reach its limit, and it's going to get exposed, right? Which is alright, which is completely alright. That's why you reiterate the solution and you come up with the solution and customize it. That's why it's a customized training plans. So that's my point being that all of this comes to us from systems thinking and understanding what ecology is and what dynamics are at play when you look at a human being. So this is basically what ecological dynamics means. What are the dynamics between a human being and their environment? How does the environment affect them? How do human beings adapt to their environments, right? And how do processes work? Because when we look at training is a process. Or when we look at any, like let's take healing for example, or let's take solving a disease for example. Everything is a process, right? We begin with some initial conditions. We have some data about, okay, like let's say if this is a sick person, this is point A, point B, point C is what we know about their sickness. That's our initial conditions. Now we provide some sort of an input based on these initial conditions. We form some assumptions based on our own knowledge, and we say, okay, this is the appropriate solution, and then we apply that solution. When we apply that solution, that's like the input. So we have a system over here, the human being. We know some initial conditions. We give them some medicines or whatever the intervention is for that disease. We apply it to them, and that's like an input. Then a process happens. The input is going to interact with the parts of the system, which is like the human being and whatever they're made up of, right? And then we are going to have some sort of an intended effect, which is either going to be appropriate or not appropriate, or like it's either going to be overwhelming, underwhelming, or just hit the spot. So then we take that data. Okay, did it work? Did it not work? And was it overwhelming? We take that data and then we feed it back to the second cycle of the treatment, the second iteration, and this is how we keep going. So this is how a system, a process, or any process works. Training is also pretty much this. Disease is also pretty much this, and healing or wellness is also pretty much this. Everything is a process. It can either be a simple process or it can be a complex process. Depends on the system that you're dealing with. Human beings are complex, adaptive in nature. So systems thinking basically gives you this transient macro lens through which you can look at anything and start looking at it as a system. What is something that I'm observing? Is this simple in nature? Is this complex in nature? Is it complicated in nature? Is this system openly communicating with the environment, or is it a closed system? So once you start looking at things like that, now what you have is like a principle, right? It's a template, and now this is not a specific solution. When you have a specific solution, you are always at risk of that solution reaching its limit and it being exposed for its limits, right? So it's not going to work everywhere. So when you have specific solutions to things, it really limits you. It really limits your ability to actually solve things. That's quite counterproductive, but that's how things work. But when you take 3 steps back and you just simply look at things as systems, right? You don't have answers, but I have a template for how to think. I'm looking at things as systems. So when I have that, now I can work my way into a solution that works for this particular thing that I'm trying to observe, right? Which is going to be individualistic in nature anyway, because when you're dealing with human beings, they're individualistic in nature. So something that worked for somebody else in one instance of time, or maybe I read 3 research papers, they told me, okay, this is a specific solution that works for XYZ, so I'm just going to take it and apply it to this person as well. Maybe there's like a small chance that it might end up working for this person, but there's a massive chance that at some point your solution is going to fail, because it was not meant for this person anyway. So that's systems thinking, that's ecological dynamics, and it gives you some very interesting insights into how to design processes that has got anything to do with human beings. I'll give you a couple of examples, like root cause analysis, right? Like we have this simplistic way of thinking, we have this default way of thinking as human beings, that there is always a cause and effect to things. But cause and effect as a model, it's a model that's applicable to simple systems that are closed in nature, right? When, like for example, like 2 plus, let's take a simple mathematical equation, like 2 plus 2 is equal to 4. I know if you look at this, like you can look at this as a system, right? Everything, what is a system? A system has input, it has parts, it has a process, and it has output, right? And there is some sort of a relationship between how the parts communicate with each other. That's what a system is. Now, based on these factors, these parameters, a system can either be complex or it can be simple. So, and then if the system is, if the boundaries between the system and its environment are open, if this environment can affect the system and the system can affect the environment, then it's an open system. It could be an adaptive system. If it's a closed system, it's probably not adaptive to its environment, so it's a closed system. I'll give you some examples. For example, 2 plus 2 is equal to 4, a simple mathematical equation. It has some parts, it has one integer, another integer, 2 and 2. They have a relationship which is like an additive relationship, right? So 2 plus 2, 4. We've established that relationship is equal to 4, right? Now let's say if we remove 1, 2 and just place like a variable there, like let's say a plus 2 is equal to 4, right? And now we can give this as many inputs as possible, or a plus 2 is equal to b. Let's say that's the equation. Now depending on what I place the value, what value I place to a, like let's say if a is 2, then my answer b is equal to 4, is going to be 4, right? If a is 3, then b is going to be 5. We have a simple input, we have a process, additive process. We have parts of the system, which is this one variable and one integer, and then we have an outcome. This is a simple system. No matter whether you do a plus 2 is equal to b in ice cold, whether you do it in this room, whether you do it outdoors in a swimming pool, the answer is always going to be the same, because this system is closed and it has got no relationship with its environment. Also, it is quite simple. You have two parts, you have a simple process, and your outcome and your input is proportional. Depending on the input, you will always have an idea of what the output is going to be, and it's never going to change, no matter how many times you run this, right? So that proportionality is not going to change. Cause, effect. This does not apply to human beings. If you simply look at human beings in terms of parts, process, the relationship that the parts have with each other, and the relationship that a human being overall has with their environment, the complexity is so much that given an input, you will never be able to predict what the output is. It's impossible to do it, right? You will never be able to accurately predict what the output is going to be. And even if you can do it for one person, or if you take a sample size of people and you've established, okay, depending on this sample size of people, we place this input, these are the findings, so we can kind of predict that for these 60 people, this sample size of people, this is what the output is going to be. Even that does not determine what the output is going to be for everyone else. If you take the same process and you run it with other human beings, at some point your answers are going to fail. They are going to reach their logical limit, because human beings are complex adaptive systems. So root cause analysis is a fallacy that a lot of us are trapped into, and it's like so deep rooted that it's going to be very difficult to unlearn this and just understand that let's find a root cause. What is the root cause? We need to solve the root cause. These things do not apply to human beings. You cannot do that. Whenever you do that, whenever you reduce your understanding down to, okay, we have found a root cause for this problem that we're trying to solve. Now let's make our entire solution about this root cause. Whenever you're doing that, you're basically reducing your lens down so much that you're kind of missing out on everything else. You're kind of missing out on the fact that this thing that I'm trying to deal with is a complex, living, adaptive entity, right? And the state that it is in, that state that it exists in right now, is a reflection of not just this one single root cause. It has not emerged from this one single root cause. It has emerged from a lot of different things, a lot of different complex adaptive experiences. So, which is basically saying that there are different ways to solve things when you're dealing with complex adaptive systems, and you solve things differently when you're dealing with simple closed systems. So a problem, we're not looking at it negatively. A problem is just constraints. How do we solve these constraints, or what constraints do we place? What input do we give to get a desired output? How do we get that desired output? That's what a problem is. Solving a disease works like that. Healing works like that. Wellness works like that. Goal-oriented training works like that. So any goal-oriented system is going to work like this, right? So when you're trying to create a goal-oriented system for, like, let's say learning something or solving something or making some sort of progress or achieving some sort of goal, you have to always keep these ecological dynamics in mind. You have to always keep systems thinking in mind and then create those processes. So root cause analysis is one thing. The second thing is rigid rules versus constraints based learning. So, when you understand ecological dynamics and systems thinking, you come to the realization that you can to some degree, you can shape the learning experience, or you can shape, if you're trying to teach a human being something, you're basically trying to make a human being achieve some sort of a goal. You're going after some sort of a desired outcome. You cannot make that person do it. There is no fixed template, oh, you follow this and you're going to end up here. Does not happen. But what you can do is you can orchestrate their environment in a way that this desired outcome is a state that they're able to achieve if they solve these constraints. So you start playing more of a passive role of an architect instead of a rigid rule-based teacher. So ecological dynamics is basically taking some of the shine away from the teacher and trying to re-understand the role of like a coach or a teacher, right? Wherein how coaches and teachers, no matter what you're trying to teach or coach or what goal you're trying to achieve, how they have been always operating is that they will have this rigid rule-based format, and whoever is in the class or whoever is in that experience, that learning experience, is going to be put through the same exact template of learning. The rules are going to be rigid. The same rules are going to apply to everyone and it never changes, right? And we fix everything for whoever is attending those, whoever is part of that experience. Ecological dynamics is reimagining the role of the teacher and applying these principles of systems thinking and ecology to understand the teacher more as just simply as a part of the learning system, right? You're just an architect that's playing a role, but you're not fixing any rules. Your role is to just create the correct constraints so that growth can emerge. Emergence is another quality of complex adaptive systems, right? That solutions, when you're talking about complex adaptive systems, solutions aren't determined, solutions aren't caused. There is no cause effect relationship. Solutions emerge when the constraints are correct and when the solutions are placed just beyond the reach of the system's current ability, right? So the solution that you're trying to achieve, a desired outcome that you're trying to achieve, is a state of the system that it can be in. Can you take that system from this state to that state will depend on what constraints you're placing on the system and what rule sets you're setting to the learning experience, so that the system itself can come up with that solution. That is basically what you're aiming for. These things are very complex. We need to, for us to really understand these things, requires more than one single video, but I'm just trying to give you some ideas. So point being that emergence, root cause fallacies, reimagining the role of the teacher as somebody that's just an architect is just a part of the process and not the entire, not this enforcer of rules. All of these things are based on ecological dynamics, and ecological dynamics is now slowly starting to creep into different industries. I hear a lot about it in jiu-jitsu. I hope to hear a lot about it in school learning as well, and it's making its way through and it's getting into the mainstream, and I'm predicting that 5 years down the line it's going to be a big thing. So you guys can start looking into it right now. When you use ecological dynamics to create a learning process, you move away from the rigid rule based format and you understand how to create constraints so that every individual's individuality and identity is respected and they can learn in their own paces. Why all of this is important, right? This is not just something fancy that it's all right even if you don't look at it and things are working out for you. But in the second part of this video, in the next video, I'm going to talk about why this is extremely important for the facilitator. If you are a coach, if you are a teacher, and if you are, if you're running a system like this where, like let's say if you have a class, a lot of people are coming to learn from you and train with you, no matter what industry you're in, and you want to make sure that your business runs, right? Fundamentally on a systems based level, if you look at your business as a complex adaptive system, if you want to make sure that you keep things running and your churn rate is at a point where you're able to sustain beyond 3-month mark, 6-month mark, 9-month mark, and you're able to retain your clients so that you're not placing a lot of load on your marketing expenses, you need to know ecological dynamics and systems thinking. And I'm going to talk about the significance of that in the next video, but I feel like it's enough for this video. So yeah, these were my thoughts. Look into ecological dynamics. There's this paper that I'm going to paste right here, and maybe I'm going to link it in the bio, and if they don't let me link it, then you guys can just message me, hit me up, and I'm going to send you the link to the paper. Super interesting, super important. Look into it, and it's going to blow your mind, and it's going to give you so many things to think about. I can't even tell you. I'm excited to talk to you guys about it. You can hit me up whenever you want. We can have a conversation about this. But yeah, those are some of my thoughts for today. I hope this was this was something, and yeah, I'll see you guys for the next one.